Welcome to this instructional video, which is going to go through a process known as implicit differentiation. Now, just to give you some background on where the word implicit comes from, there's two types of functions. There are explicit functions, which is all we've looked at so far. So an explicit function means something like y equals x squared minus 3, or f of x equals 7x minus 4. The y equals or the f of x has been isolated by itself on one side of the equal sign. Versus this type of function over here, which would be referred to as implicitly defined functions. You don't have your variables rearranged and isolated. Now the first one is easy enough that you probably could rearrange it to get y equals. And the problem now would be y equals plus or minus the square root of 25 minus x squared. And then the issue would be, well, is it the positive piece of this is x squared plus y squared equals 25 is a circle. If you didn't know that, that's a circle that has its radius of 5. This would be the top half of the circle. The negative would be the lower half of the circle. Now, if I was trying to get the derivative of this function as it sits, I would have to know a process called implicit differentiation. So let's take this second one. If I was to say, well, why don't you just rearrange and isolate and get y equals by itself for this one? Well, it just says it could be, but it would be a much more complicated situation to try and get just a single y equals and all x's over on the other side given this function. Just looking at the fact that you have these multiple y's, the y cubed and a y, makes it much more challenging to rearrange that. So we need a better plan than say, well, I'll just rearrange and get the variable by itself. As these progress, we'll get much more complicated implicit functions that it's, for all intents and purposes, impossible to rearrange them. So we have to learn how to do the process called implicit differentiation. Okay, so this just says it's a way to find the derivative without isolating for y, and essentially we're just going to take the derivative of both sides of the equation. And the one thing we're going to have to watch for, though, is when we differentiate. So if we're finding dy over dx, we're differentiating y with respect to x. Now, we've done that already. Let's suppose I look at this example. So y equals, 3x to the fourth plus 7x. Well, the derivative of y, or y, so there's two ways you can write it. Y prime, that's the symbol that means the derivative of y, would be 12x to the 3 plus 7. X, the derivative of 7x is just a 7. I could have also written it as dy over dx, means the same thing. That would also be correct. Now, we haven't had to look at it really this carefully, but when we get into implicit differentiation, this is really what we did. So I took the derivative of the letter y, which is dy over dx. I then treat it, without me saying this like a chain rule. So I went 4 times 3, so 4 times 3 was 12. I left the x the way it was. I took one off the exponent. Then I took the derivative of the letter x with respect to the variable x, and I got a 1, plus, again, treat this like a chain rule. You say, what the heck is he doing? Why is he doing that? Why is he confusing things? You'll see why here in a second. So 1 times 7 is 7. Take one off your exponent. Then you took the derivative of x with respect to x, and I got 1. Well, what's going to be different now is these might not be x's. They might be the variable y. So for example, if I have x cubed plus y to the fourth equals 7y to the sixth plus 8x cubed, implicit differentiation is going to get us to go left or right, just both sides of the equation. Well, the derivative of x cubed is just like it always is, 3x squared. Now, this is where our brain's got to think a little bit differently. you have to treat this like I was trying to show you up here. It's really a chain rule. So it's 4. So 4 times the letter y. Take one off your exponent, 3. Now here's the difference. Here I was differentiating an x, and the derivative of x was 1. That's why nothing showed up after it. But in this scenario, it's 4 times y. Take one off the exponent, 3. I need the derivative of the letter y. Well, we know that the symbol for the derivative of the letter y is dy over dx. Now, you could also insert y prime here. I don't suggest you do it when you're doing implicit differentiation, just because what happens is all of a sudden y primes get blended in with y to the 3's, and you get your exponents mixed up, and you think that a y prime is a y to the 1st or something like that. There'll be no confusing dy over dx for y to the 1st. All right, that's the derivative of this one, equals, so 6 times 7, 42. Now notice this is a variable y, so leave your variable, take one off your exponent. Now you need to differentiate this variable. So because it's a y, it'll be dy over x, dy over dx. 8 times 3, 24, x squared, but this time it's an x, so the derivative of the letter x is a 1. You don't need to put anything after it. So notice anytime you differentiate a letter y, you're getting this dy dx stuck after it. And so why is that showing up there? My best descriptor I can give you is that it's a chain rule. You have to envision that you're differentiating this y to the 4th as if it's a chain rule. 4, leave this as it is, take one off your bracket, or off your exponent, sorry, and then differentiate what's in your bracket. And because it's a letter y, that's the symbol that means the derivative of the letter y. Like we did over here. Look, we had a y, these symbols. Now, if you're nice and neat and you want to put y prime in where the dy dx's are, you absolutely can. But just be very, very careful that they don't kind of get interchanged for a y to the 1st power. Now, this would not be finished. That would be the differentiation line. Now, what you do is you group all the dy dx's on one side. So you go 4y cubed. You bring this one over. So 4y cubed dy dx. Take away 42 y to the 5th dy dx. Leave this one where it is. And bring the other non-dy dx term over to that side. So take away 3x squared. You're now going to factor out dy dx to be 4y to the 3rd. Take away 42 y to the 5th equals 24x squared minus 3x squared. Now, do you remember what our goal was? Our goal was to find the derivative. Well, that's what this symbol is. So I want to now get dy dx by itself, just like over here, dy dx equaled something like this. So to do that, I would divide both sides by 4y cubed minus 42y to the 5th. 4y cubed minus 42y to the 5th. This, we'll get rid of this. And now we will have what we're looking for. Dy dx is 24x squared minus 3x squared divided by 4y cubed minus 42y to the 5th. So notice that your derivative in this case is what we would refer to as implicit. All that means is that in your derivative there are both the x's and the y's. You could still find slope. This is still slope. The only difference I would need with an explicit derivative like this one, all you need is the x value. It will spit out your slope. With an implicit one, the difference is you need both coordinates, your x and your y, so you can fill in x and y, and it will tell you the slope at that particular ordered pair. But that process that I just did is referred to as implicit differentiation. Okay, so let's throw a few at you here and see how you make out. So this was the one we had mentioned earlier. It's called the Folium of Descartes. It has a special name. So it says find y prime. I know that y prime is the same as dy over dx. And then it wants us to find the tangent to the curve at 3, 3. And then it says at what points on the curve is a tangent line horizontal. All right, so let's take the derivative of this. Left to right, x cubed, the derivative is 3x squared. Now remember, treat this as if it's a chain rule. Y in brackets to the 3rd. So it's 3y. Take one off the exponent. Take the derivative of what's in the brackets, which is a y. So the derivative of the letter y is a dy dx. You don't need that here because you're differentiating an x. The derivative of the letter x is just the number 1. Equals. Now, be careful on the right side. This is 6x multiplied by y. So when you get the same variable, or sorry, different variables in the same term, you must treat it as a product rule. 6x would be considered the first. So derivative of the first multiplied by the second. So 6x is the first, and the y is the second. Derivative of the first was 6 multiplied by the second, plus the first, 6x. Now I need the derivative of the second, which is just the letter y. Well, the derivative of the letter y, we've talked about many times now, is dy dx. All right, now you're going to move all the dy dx's to one side, and you're going to, as you get more comfortable with this, you can, as you move them, factor out the dy dx. So I'm just going to write dy dx, and put my bracket, so I'm going to have my 3y squared. This is going to move over and become minus 6x equals, I'll have 6y, and then the 3x squared is going to go the other way. Now to get dy dx by itself, I'll divide both sides by this. So dy dx is 6y, take away 3x squared over 3y squared minus 6x. So that's the first question they asked. They said find the equation of the tangent to this curve at 3, 3. So equation of a tangent is found by using point slope. Well, they gave me the point, so x1 and y1 are both 3 because your ordered pair is 3, 3, but I need my slope. So let's get the slope, which is dy dx. So the m will be 6, y is 3, and x is also 3 because the ordered pair was 3, 3. I don't know if you happen to notice, but this is 6 times 3. The numerator, 6 times 3 minus 3 onto 3 squared, is the exact same as the denominator except subtracted in the opposite order. Well, we know what happens. We don't have to do all the calculations, or we shouldn't have to. You should know that gives you a negative 1. So the slope of the tangent is negative 1, and your point we just used is 3, 3. So y minus 3 equals m onto x minus x1. Y minus 3 is negative x plus 3. We'll go general form, so let's move this way. X plus y, take away 6, is equal to 0. Now the last part says at what points on the curve is the tangent line horizontal? Now this is a little bit more confusing. So a horizontal line, you need to know that means that the slope is 0. Horizontal lines have slope 0. Well, that's telling you that dy dx, which is slope, is equal to 0. So 0 is equal to 6y minus 3x squared over 3y squared minus 6x. Well, the only way that a fraction can equal 0 is if the numerator is 0. So based on what I see here, I know then that's the numerator, 6y, take away 3x squared has to be equal to 0. The denominator can't be 0 because that's undefined. Now you look here and say, well, that's a problem. I don't know. How do I know? I've got two different variables. Well, you need a second equation. Lucky for you, we have one up here which says x cubed plus, what is it, x cubed plus y cubed is 6xy. So these are your two equations you got to kind of work together with. This is the derivative equation, and this is the actual original, but it's the same x and y is being referred to in both of these. Well, I would think I'd rearrange. This one's probably the easiest one to rearrange. Let's get 6y equals 3x squared. So the easiest to isolate is to get y equals. Y would be 3 over 6x squared, or y equals a half of x squared. Take that and put it in here for the letter y. So x cubed plus 1/2 of x squared cubed equals 6x. And instead of y, I'm going to put 1/2 x squared. All right, let's see what that gives me. X to the third plus 1/8 x to the sixth equals 1/2 of 6 is 3 x to the third. All right, so let's make this equal to 0. I'm going to have 1/8 x to the sixth, take away 2x cubed. If you move that over there, you just group those together, you're going to get minus 2x cubed. I'm not a big fan of this fraction that's here, so let's get rid of that by multiplying everything by 8. X to the sixth minus 16x cubed would be equal to 0. We have a GCF of x to the third onto x to the third minus 16 is equal to 0. Well, this is multiplied by this, and the answer is 0. That could only happen if x was 0, right? X was 0 would make 0 times this would give me 0. Or the second bracket, x cubed minus 16 would have to equal 0, which means that x cubed is 16, x is the cube root of 16. Those are the two x coordinates where you would draw tangents that would end up being horizontal. Now, cube root of 16, let me guess. So cube root of 16 is 2 point something. Let's go back and look at that graph and see. So 0 and 2 point something. So 0, yeah, it does look like if I drew a tangent there, it'd be horizontal. And this point right here looks like the other one. So assuming that that's our 2 point something. And there is just the 2 points that you would draw that would have horizontal tangents. All right, now, again, I'm more concerned with the process of implicit differentiation for right now, but we can't lose sight of this information, that derivatives are slopes and how slopes tie in with equations of lines and parallel and perpendicular and horizontal and some of those keywords that you'll run into. Let's do the derivative of this circle. So we'll do it implicitly. So x squared plus y squared is 25. Find the derivative of this would just be 2x. Remember, the letter y must be treated as a chain rule. So 2y to the 1, differentiate your letter y, dy dx, constant is 0. So we just have the 1 dy dx. Take this to the other side. Divide both sides by 2y. So negative 2x over 2y. Get rid of the 2's. There's your derivative of this circle. That's part A. Part B. What's the equation of the tangent at the point 3, 4? So let's find the slope by filling in my x and y. So it would be negative 3/4. Y minus y1 equals your slope multiplied by x minus x1. Let's multiply everything by 4. That'll get rid of the 4 here. Negative 3x plus 9, general form. There's the equation of the tangent drawn to the ordered pair, or to that circle at the ordered pair 3, 4. Okay, so let's just throw a few, let's skip ahead a little bit. Let's go to these ones that are a little bit more challenging. So let's look at, we'll do all of them. Let's do the bottom two. Oops. Okay. So when you have your x, y's mixed together, you must treat this as a product. So 3x squared would be the first, y squared would be the second. 4x would be the first, y would be the second. Product rule. Derivative of the first multiplied by the second plus the first multiplied by the derivative of the second. 2y dy dx equals 4x squared, the derivative is 8x, minus, now you got to be careful, this negative needs to go through the whole derivative, so put it in brackets. The derivative of the first, 4, multiplied by the second, plus the first, 4x, the derivative of the second, dy over dx. Let's clean this up a little bit. So I got 6x y squared. This is all multiplied together, so 3 times 2 is 6. X squared y with the dy dx equals 8x, subtract 4y, subtract 4x, dy dx. Collect the dy dx's on one side, and I'm going to factor it out at the same time. So I'll have 6x squared y. This is moving over, so it'll switch to plus 4x. Now all the rest of the terms do not have a dy dx associated with them. So that's this one will move over. Therefore, your dy dx will be this. Divided by this. All right, I'm going to do this one next. I don't have enough room here, so I'll just grab this and put it on the next page. So you can just jot it down on your page if you want. And I'll get this ready. All right, so we're all set to go here. Implicit differentiation, because it's an implicitly defined function. X's and Y's are all mixed up throughout. So we go left to right. 15x squared plus product rule. Derivative of the first is just a 1 multiplied by the second plus the first multiplied by the derivative of the second equals product rule. Derivative of the first multiplied by the second plus the first multiplied by the derivative of the second. All right, so now I have, I screwed up something here. I forgot my dy dx here. So right, there you go. Right, because I was differentiating a y. 3y to the 2, derivative of the letter y, dy dx. Okay, so I'm going to start doing multiple things at once here, which you should be able to follow without too much trouble. So I'm going to clean this up. So it's 2xy. I'm going to move this over and clean it up. So it's going to become minus 15 x cubed y squared. I'll be left with 15 x squared y cubed. These two are going to move to this side, minus 15x squared minus y squared. So dy dx will be this divided by this. 15x squared y cubed minus 15x squared. All of that over 2xy minus 15x cubed y squared. There you have it, implicit differentiation. It's a good checkup, I guess. We'll look at this one real quick. So it's quite similar to what we were just doing. So let's go left to right. 2x minus. Negatives are really important. You put your derivative in brackets because the negative needs to go through the whole derivative, not just the first term. Product rule. Derivative of the first times the second plus the first. Multiply that by the derivative of the second. Plus 2y dy dx. Product rule. Derivative of the first, multiplied by the second, plus the first. Now the derivative of y cubed is 3y squared dy dx. Constant, derivative of a constant is 0. Okay, so now let's get all the dy dx's grouped together and cleaned up everything as we go as well here. So it's going to be dy. If you get really good at it, you could. I have no problem with students going right from here to dy dx equals, where you kind of keep track of what's going to be on this side, what would be on this side, and then put it on the bottom here. Again, if you're comfortable with that, have at it. Oh, I won't do that on you yet, though. So dy dx, we're going to have this negative is going to come in here and make this negative 3 times 2, so it's going to be negative 6 x to the third y. This one's positive 15 xy squared, so it's coming this way, so it's going to be minus 15 x y squared. Now you might have said, I don't want those to have negatives in front of them and move these this way. It doesn't really matter. I'm going to just keep it like it is. So 5y cubed. Now this one's going to switch sides. This would be negative, so it's going to become positive on the other side. 9x squared y squared dy dx is 5y cubed minus 2x, 9x squared y squared, all of that over negative 6x cubed y minus 15xy squared. There you have it, implicit differentiation. Okay, I got a couple with a little twist to them just so that we're ready for it in case we run into it. So the first one with the twist is when you've got a chain rule. So we'll see how we manage that. Let's see what we do with this. So it's the derivative line's no different than you're used to seeing, hopefully. So the derivative of x squared is 2x minus, I need product rule, so derivative of the first multiplied by the second plus the first, multiply that by the derivative of the second. There's your derivative of that. Okay, now this is a chain rule, so it's going to be 5, leave your function, to the 4. Now differentiate inside the brackets, 10x minus 8, and then the derivative of the letter y is dy dx. So that in itself is really nothing too exciting. Here's the little catch. When I go to isolate and get the dy dx's together, I can't just take this and move it because this is multiplied by all this stuff out in front. So to me, I find the easiest way to deal with this is as follows. So just the left side, just maybe distribute your negative through here, negative 3y, negative 3x, dy dx. All right, now here's the catch. You need to be able to envision that this stuff out in front is just like having a constant in front of a bracket. And we are going to take that expression and we're going to distribute it into the first term, and then we're going to distribute it into this term. So when I do that, it's going to be 5 with this to the 4th times 10x. Well, I can multiply the 5 and the 10x and say this is 50x onto 5x squared minus 8y to the 4th. That's what I've highlighted times 10x. Now what I've highlighted times this, I'm going to multiply the 8 and the 5 and get minus 40, 5x squared minus 8y to the 4th, and there will be a dy dx stuck at the end of this. And now you're just going to move, this is all one term, we're going to move it around. So we're going to have dy dx bracket, so negative 3x from this term. This whole thing is going to go to the other side. It'll switch to plus 40 onto 5x squared minus 8y to the 4th. Close that off. This is going to stay where it is, so 50x, 5x squared minus 8y to the 4th. These two are going to switch sides, so negative 2x and a plus 3y. And ultimately we will get dy dx is equal to this, 50x, 5x squared minus 8y to the 4th, take away 2x plus 3y. That will all be divided by this. Negative 3x plus 40 onto 5x squared minus 8y to the 4th power. All right, so you have to distribute whatever's out in front of your chain rule into that second part of the chain rule. And that'll allow you then to freely move your terms around. All right, one quick last one is involving trig functions. So again, nothing too exciting other than you got to know your trig rules. Let's just, I don't want to overcomplicate things. Let's just make this just 3y to the 5th. We won't put the x in there because then you get a product rule in a trig function. It gets pretty complicated. Okay, so it's cotangent u. So this is just going to be treated as 3y to the 5th. It will be negative cosecant squared of u multiplied by du. 15 y to the 4th. Differentiate your y. dy dy dx plus chain rule 3 secant 5x to the 2. Differentiate in the brackets, it is secant u tangent u times du equals derivative of 4x cubed is 12x squared. Now this would be 6y to the negative 2. So my derivative is negative 12 y to the negative 3, and then differentiate your y, dy over dx. Okay, so this is all just considered 1. So my dy dx is going to be dy dx. I'll have this negative, how you write this doesn't really matter. 3y to the 5th, 15y to the 4th. This is my other dy dx term, so it's going to move over and become plus 12y to the negative 3 equals, this is a non-dy dx, and then this is all one term because it's all multiplied together. Now if you want to clean it up, this it's all multiplied together, so you can multiply the 5 and the 3 if you want. Move it to the other side and say, well, it's 15 secant squared 5x, and then another secant 5x. You could have actually made it cubed if you wanted to, and then tangent 5x. And then finally, hopefully I didn't miss anything. I got that. We should be good. dy dx is equal to 12x squared minus 15 secant squared 5x secant 5x tangent 5x, all of that over negative cosecant squared 3y to the 5th onto 15y to the 4th plus 12y to the negative 3. Now, again, it looks from the outside looking in, from the outside looking in, this looks very complicated. But if you kind of look at it in more detail from your perspective, understanding a little bit more of what's going on here, a lot of it is just moving terms around. So once you get that first line out of the way, your differentiation line, the rest of the question is just rearranging and isolating for dy dx. All right, that wraps up how to do what's called implicit differentiation. There will be a set of practice questions found in your class notebook. Once you get some comfort level with this, then I suggest you try the formative assessment to make sure that you're on the right track. Thanks for watching, and best of luck.